Let's go over a quick recap of some of the changes we've made to the code so everyone's on the same page. We added a kickstand subsystem in, and it just has a potentiometer that we just resoldered. We have not yet tested, and a Jaguar motor that will drive the actuator that lowers the caster wheel and lifts up the robot so we can grab onto the climb. So this is really exciting that this looks like it's working. There is no initial default command. Like the drive system, its initial default command is the drive command. And so it's looking for your controller to be ready to drive. Instead, we will just look for you to press the right bumper or left bumper. Those used to be our grabber. Since we had to switch to a simpler design for now, we can use those for kickstand up and kickstand down. Currently, they're set to only move while their bumpers are being held down, but we can also change those commands. You can see the two commands, kickstand up, kickstand down, yeah, good. We can change that is finished. We'll also pull the potentiometer's voltage that it's returning, and we can use their signal to determine how far it's extended. So we just auto shut this off when it's all the way up. Likewise, when this one, when the kickstand has been fully extended, we can shut it off based on the reading from the potentiometer here in the subsystem. We haven't wired that up. Right now we can just sort of eyeball it and see how we're climbing. We're also trying to transition the ARM command and how the subsystem here works. The subsystem is going to, this is sort of where what we're trying to avoid having to use, where we have to think of a constantly running command that'll fight to hold at this position through a varying sort of weights and torques. It's a hot and very difficult mess, especially since we really need to sink our teeth into studying PID software engineering during the off season, so we can get our heads around that in a more professional manner. Meanwhile, we're trying to upgrade the worm gear so we can have a mechanical solution rather than this arm hold at solution. So our goal is to get rid of this, and this file. This whole complex set that Jeff and I worked on some of these most recently. We can get rid of them all and just have a move to function, just like a drive to angle. We'll just say what degree we want it changed, and it'll compute that. The angle change based on our encoder readings. It'll have that conversion rate to encoder readings and move to that angle using the similar PID methodology. So Charlie worked on this, and we have this sort roughly outlined, and it looks like it works, but it then shuts off as it's supposed to do, and immediately drops. So we think this algorithm works just fine. We just need to test it on a system with the upgraded worm gear. Hopefully that works. If not, then we'll have to keep on revising this and studying PID and studying this arm hold at after we bag the robot. We'll have to build another mock-up and try to work out the software problem on a separate test system. Charlie and I also worked on the drive command, and so what we're trying to do here is when we went forward, we noticed that at slow speeds and doing small adjustments, it was really frustrating because sometimes they wouldn't drive evenly. One side would start sooner, and we would be a little wobbly. If this is one of the solutions we could do is switch this off of arcade drive and have two joysticks being used, one on each tread. And so the driver could manually adjust just from the feel and how the robot responds, they can have a greater sense of control because each side, the left and the right motor set, is bound to a different joystick. And so you can balance that out on your own. And that might be required for us, especially if we're trying to awkwardly climb up a platform. And so we might really need to have only one side of our treads move. So I think I've been convincing myself to switch to tank drive and to talk to our driver, Anthony, about this, and how he would like us to proceed there. But in the meanwhile, we can compensate for drift. If we are sticking with this, we can look for moments where we weren't moving but are now trying to drive straight ahead, no left or right, but definitely trying to drive forward. And if we weren't moving, but now all of a sudden I'm driving straight forward and not at all left or right, then let's flip a couple switches to note that I'm now trying to drive straight, and otherwise I'm not if I'm standing still or just spinning in a circle, or in a curve. Then ignore that and instead note that I'm trying to drive straight and write down my current gyroscope angle. And now I'll need if I'm trying to drive straight here, then automatically return an arcade drive minus the opposite of the angle that I'm trying to do, times probably 0.03 or some sort of constant that will convert that to the power proportional to the angle that I'm trying to correct for. And this quick turn to angle commands don't seem to be working out too well. We need to figure out why, only because we may want to use this structure for the arm so that we can say, hey, move the arm to this angle on the D-pad, and it'll just snap to that angle. That would be great, especially if the new worm gear holds and we can institute that arm move to command. That would be super. And so we will need to figure out how we bind a range of motion to the POV, which is the D-pad on an Xbox. Anyway, that's what we will pick at remotely for today and tomorrow, and then we'll test it all out on Monday.